Teaching single-digit division, or even double-digit division if the numbers are small, can be done with manipulatives and pictures, and that's a good foundation for students. Once they've done that, they move into long division. This is much more complicated for students, and we need to make sure we teach it in a way that allows some flexibility, that there's more than one way to get to the right answer. We also want answers to be reasonable. Take a look at these problems and see if you can complete them both as a student who may be struggling, who may have lower level knowledge of division and numbers, and maybe with a student who is a little bit more advanced. Try both ways, see what you come up with, pause the video, and when you're done, start again and see if your thinking aligns with mine. It's important to remember that there are many ways to do this, so your numbers may not be exactly what mine are, but see if you're using the same kind of thinking. If I'm a student who's struggling a little bit with division and large numbers, I may say, I know that there are 5 20s in 100. So I'm going to start with a guess of 5. I know that 5 20s are 100, so I'm going to subtract to see what I have left. I have 409 left. That's still quite a bit. I might double my guess to see where that gets me. So instead of 5, I'm going to guess 10. If 5 20s are 100, then double that is going to be 200. That's pretty good. I'm going to do that again. And I get to the point where I know I can't divide anymore. So I have 25, remainder 9. 25, remainder 9. Another student might look at that same problem and say, I know there are 5 20s in 100, and I know that 5 times that would give me the 500. So I'm going to right off the bat say 5 times 5 is 25. 25 times 20 is going to be 500, subtract 9, remainder 9. Much more efficient, but still mathematical thinking, still place value. In the next problem, we can use that same way of thinking. A student might look at this problem and say, I want to know how many 320s there are in 6,387. I know that there are at least 3 320s in 1,000. So if I take that times 6, that would be 18. So I'm going to guess 18. Then I need to figure out how much that would be. If I take 320 18 times, how much is that? Now for some students, it's good to divide this up into 2 different procedures. For example, they can say, well, let's see, if I took 18 times 3 hundreds, that would be 24. That would be 54 hundreds. I'm using this H to mean hundreds because it makes it easier. But I still haven't taken the 20 times the 18, so I'll have to take the 18 times 20, which is like 2 tens, so that would be 36. But that's actually 36 tens, which would be 360. So now if I take that and I add both of those together, then I'm going to get 5,760. So that's how much I've already used. And I need to subtract to see what I have left. And I have 627. Well, I know I can at least get one more out of that. 2 times this would be 640, which is too much. So 1 would be 320. And if I subtract, I get 307. So I got 19 320s out of that, and I have a remainder of 307. Again, when students are doing this, they're having to think about the value of the number. They're having to use skills like estimation or breaking things apart to figure it out. They're not just following rules that are mindless that they don't understand, and that's what counts. It also counts that they can do the problem in different ways. They can look at it this way or this way. They can approach a problem in a way that makes sense to them based on the understanding that they have. This time, figure out the answer to the same 2 problems, But do this in the way that is traditionally taught, probably the way that you were taught. When we teach long division with the typical steps, the procedure, the shortcut, what kind of thinking are we doing? Can you incorporate any place value thinking, or at least thinking about the value of the number into your traditional steps? Pause the video and see if you can find the answer to these two problems, explaining your thinking step by step as you go in a more traditional way. So what would this look like? In a traditional way, we would say, how many 20s are there in 5? None. How many 20s are there in 50? 2. 2 times 20 is 40. We subtract to see what we have left. What's important here is that this is not really a 2, it's really 2 10s. So we know that there are at least 2 10s in the answer. We know there are at least 20 20s in 509. As we subtract and bring down the next number, we're finding out what we have left, what we haven't divided yet. How many 20s are there in this number? Well, without even looking at just the first digit or the second digit, most students will know that there are 5 20s in 100, so that gets us close. We still haven't used the 9, and our answer is 25, remainder 9. In the next problem, we're thinking, how many 320s are there in 6? None. How about 63? None. How about 638? Well, I probably can get 1 or 2 out of there. How am I going to know for sure? Well, 2 of these would be 640. That's going to be a little too much, so I'm just going to do 1, 320, and I'm going to subtract to see what I haven't used yet. So what I haven't used yet is 318 tens, but I don't have a number in the ones place, so I have to bring that down. So my next question then is, how many 320s are there in 3,187? That's a lot. So I think I'm going to try 9 and see what happens with that. So if I come down here and I just calculate just to make sure before I do this, can I really get 9 out of there? And my answer is yes, I can. So 9 320s is 2,880, and I subtract to see what I have left, and I have 307, so I have a remainder of 307. So as I put this 1 up here, when I got to that point, what I was really determining is, I was saying there are at least 10 320s in 6,387, because that 1 is in the tens place. So I know that there are at least 10. And when I keep dividing with what I haven't used yet, I find out that indeed there are almost 20, which was my initial prediction when I started. I thought, well, there could be 1, there could be 2, I'll have to figure it out. So doing long division still needs to be logical. There needs to be some thinking about value. We don't want to get to the point where we're just saying, how many 2s are in this? Multiply, subtract, bring down, add the next number, whatever these rules are. That makes no sense. We need to use language that represents the value of the real number at some point, even if we don't do it initially. And when we're bringing down and subtracting, we need to use language like, well, I still haven't divided this yet. I haven't found out how many 20s there are in this. That's why I'm doing that. The why in long division is very important.